In this tutorial, you'll learn about the Mecanim animation system and create a scene that looks like this, with a barrel jumping robot that can also jump from ledges and naturally shoot lasers at a spherical object in the sky. To see the finished scene, open the Finished Scenes folder and open the scene file called Tutorial Done. To start the tutorial, open the tutorial folder at the bottom and load the scene called Tutorial Start. Let's take a look at the robot character we're going to animate. First off, he contains no animation attached to him whatsoever. We can leave import animation completely unchecked. However, we do want to make him a rig that can receive animation. Within the rig section of the import settings for this robot, I'm going to choose the type of character. So this particular character is a humanoid, i.e. some kind of biped type character. And the avatar definition is basically an asset that will get created within the FBX hierarchy. And this is an asset that stores all of the bone mapping and muscle definition. So I can say create from this model and hit apply. And when I go to configure, I can assign all of the bones of the character to the mapping of the avatar. So I can do this automatically by going to mapping at the bottom and choosing auto map. This then applies the bones from the hierarchy based on the order in the hierarchy and also the naming of the bones. So if you're working on a character that needs to go into this system, make sure that you have a standardized character set up that looks something like this, or refer to the other materials that we've put on the asset store for information on how you should put your characters together. Now you'll notice that some of the bones here are in red, and that's because Mecanim would like your character to be in a T-pose. We can fix this simply by going to the pose drop down at the bottom and selecting Enforce T-pose. Now that's completely set up. My character is ready to go. But one other thing that's worth mentioning in this area is that we can go to muscles. I'm just going to apply those settings. And we can apply constraints to different parts of the body if we want to. So we've got muscle group previews, we've got per muscle settings and additional settings. And when we're happy with these settings, we can hit apply and then choose done to go back to our scene. So let's get started constructing our character. First of all, drag and drop the FBX file into the scene. I'm going to place him at the foot of the first ramp. Then, because this scene is set up with light probes, which will enable dynamic light to be projected onto the character, we need to drill down into our robot and set the actual mesh renderer to use these light probes. So expand the parent object called robot, select robot 2 and check the box for use light probes in the skinned mesh renderer component. You should now see that the robot is nicely lit. We can now collapse the parent object. Now we're going to apply all of these animation files, and you can see that they're just constructed with some very basic geometry to show how they actually work. So if you have animation files from various sources and they have a vague mesh applied to them, you'll be able to preview them in Unity 4 now. With my walk forward, for example, I can go to Animations tab and I can see the clip that we've made for that. So Unity 4 contains a complete solution for bringing in your animation files, selecting part of the timeline of that animation and creating loopable clips that you can retarget to any character that you want. What I'm going to do with that is start to build up a controller for this character. So when I select my character, I can see that there's a new type of component, the animator. And what this means is that it's a complete state machine that we're going to use to control this character. So if you go to Window and Animator, you can open up the animator. Currently we're looking at the animator for the finished game that we were working on before. But we want to start from scratch and learn how to do this. So select the tutorial folder and go to Create, Animator Controller. And we'll call this My Bot Control. As a brand new animator, you can see here that we're looking at this new one, Tutorial/My Bot Controller. And you can see that the animator window has changed to show us details of this new state machine. It's currently got no states within it, and it's got no parameters either, and we just have a single base layer of animation to get started with. So how do we use this? Well, Let's begin by docking it down here so we can still see our character. So what we need to do first off is apply this to our animator component. So I'm going to drag and drop that as the asset to use. Then, because this animator is going to drive our character around by using the root motion from the animation, we'll make sure that that box is checked. We're also going to make this a rigid body character so that he can react with physics. So we're going to check animate physics also. So now that this asset is applied to our character, we can start to apply animation to the controller and have it affect our character. So let's return to our animations folder. And we'll find the idols FBX file. So in this FBX file, you'll see a single clip called idle. And if I hit preview, you can see it's just a clip of the guy kind of standing still, which is set to loop. To put this into our animator controller, I'm just going to expand the hierarchy of that FBX, locate the clip at the bottom, which has a play button icon, and drop it into our animator controller. You can move around the animator controller by holding down Alt and dragging. Note that it turns orange because this is the default clip to play for this animator. So if I now press play, you can see that my character has that animation. So whilst you can drag in individual clips like idle for example, what we can also do is to bring in several clips into something called a blend tree. We can right click and go create state from new blend tree. I'm going to name this blend tree walk back. I'll double click on it to go into it, and you can see now I'm in a slightly different view, but I have a breadcrumb trail to get back at the top of the animator window. So what I do with the blend tree is to bring in a number of different animations and set up the blend tree to blend them together as different inputs are being used. So for example, in this blend tree, I'm going to have 3 motions, one to walk back in a straight line and 2 more to walk left and to the right whilst walking backward. So let's create 3 motion fields. Click on the plus icon and choose add motion field 3 times. Now we have 3 slots into which animation can be placed. We've created a walk back clip for you. So if you select the walk back FBX and select the clip, you'll see a walking back animation. And we can drag and drop that into our blend tree. So reselect the blend tree, drill down into walk back, and drag and drop the walk back clip into the middle of the 3 slots. Then go to walk back and turn, and drag the walk back turn left into the first slot and walk back turn right into the 3rd slot. So we now have a blend tree that's going to take these 3 animations and blend them together based on a particular parameter. So a parameter in the animator is something that can receive information and apply it to the animator. So in this instance, we're going to be receiving information from input. So I'm going to create a parameter that we're going to use for speed and another for direction. So click on the plus icon next to parameters and choose float and name it speed. Then make a second float and name it direction. The capitalization of these parameters is important because we're referring to it in the script. So this blend tree automatically has chosen the first parameter I've put into the system. But I want this to be based on direction because it's going to choose whether we're walking in a straight line backward or turning left or turning right. So I'm going to change that to direction at the top. Then, because this is based on input, if you've used Unity before, you'll know that the input system is based on a value from -1 to +1. So the lower threshold, this number here, should be set to a value of -1. The Automate Thresholds checkbox will mean that Unity is setting up threshold values for all of your motion clips based on that information. So in this instance, it's set the lower threshold to -1, the center to 0, which is our kind of idle state for input, and the positive state to a value of 1. So now I'm going to go back to my base layer, and I'm going to create a transition from idle into walk back. So this means right-clicking on a state and choosing Make Transition. I then get this arrow that's attached to my cursor. I click on the state I want to go to, and I can then click on the transition I've just made to set up conditions for it. So we need a condition, much like an if statement, to say what needs to happen in order for us to go from one state to another. So I'm going to say that my speed value should be less than minus 0.1. So when I start to press the walk back key or my down arrow, for example, then I'm going to transition into this. I'm then going to right click on my walk back, make transition, and click back on idle. This time, selecting the returning transition to idle, I'm going to say that if my speed is greater than minus 0.1, then we'll transition back. So in order for us to get into this walk back state, we're going to use the speed value, and then once we're in that state, we're using direction to control how it looks. And I can preview that blend tree by pressing the play button on the preview window and by dragging the direction slider to see how it behaves. It should be noted that you can also drag in any character with an avatar into the preview window in order to use that as your previewing character. So for example, I can go into my tutorial folder and drag and drop my robot in and use him as my preview. So now my character is set up to walk back, but we need to actually give the parameters in our animator a value, and we do this using scripting. Let's return to selecting our robot in the hierarchy, and we're going to drag on a script that we've already written for you. Select the scripts folder in the project panel and drag over bot control script. The bot control script also requires rigid body and capsule collider, so you'll see that those components have been added at the same time. Let's double click on the icon for the script to launch it and have a look at how it's providing those parameters some values. You'll see that all the scripts in this project have been commented, so you can read through at your leisure to see how the script works. We're going to be pointing out various things throughout the tutorial to show you how they relate to what we're doing. In this particular instance, we want to look at how those values are set. You can see that on line 48, we have float values set up for horizontal and vertical. So they're grabbing the axis controls for input. We then use set float to send particular parameters a value. So we're sending speed the value of my vertical axis and direction the value of the horizontal axis. Anim simply refers to my animator, which I've set up in a private variable up at the top and then initialized using start and get component. Switch back to Unity now. Let's set up the values for our rigid body and capsule collider in order to make it suitable for the character. First off, set the mass of the rigid body to 60. Then open his constraints and check the boxes for freeze rotation X, Y, and Z. This means that the animator is in control of the rigid body's rotation, and we needn't allow the physics engine to intervene as it's being controlled directly by this. For the capsule collider, set the Y center value to a value of 1, moving it up. Then set the height to a value of 2 and a radius of 0.3. Now that this script is applied and we have our components set up for the character, we're going to press play and see our character using the walk back state. So also bear in mind that the animator window will preview as the game is playing, but given that Unity will switch to the game view, you need to have the animator docked somewhere away from the game view so that you can see both at the same time. I'm going to move back to my base layer and then play the game, and I'm going to walk backward and turn in different directions. So I can see if I go into my blend tree and continue to play the game, you can see that it's blending through those different values based on the input values that I'm using with the keyboard sent to the animator via the script. Now let's make some more detailed animation by using nested blend trees to create walk and run animations for the character. Return to the animator panel and go back to the base layer. Right click and choose Create State from New Blend Tree. We'll name this state Locomotion. Enter the blend tree by double clicking on it and you'll see the same empty blend tree that we had before. This time, in the motion list, click the plus button, but instead of add motion field, choose new blend tree. Do this twice. So we now have two new blend trees coming off of the original blend tree. One of these is going to be for walking animations and the other is going to be for run. Select the uppermost blend tree and create 3 motion fields by clicking on the plus icon 3 times. Again, we've created assets for you for this, so simply select the animations folder in the project panel and expand the walk forward animation clip. Scroll to the bottom and drag and drop the walk forward clip into the second of the 3 motion fields. Then collapse this and open up walk forward and turns. Scroll to the bottom to find the animation clips and drag walk forward turn left to the first slot and walk forward turn right to the third slot. If you're losing sight of your blend tree, simply drag with Alt within the animator window to get back to where you need to be. Select the blend tree again if you've lost it, and remember that because we're receiving input with this, yet again the lower threshold needs to be set to a value of -1. And naturally this blend tree is also based on direction, so ensure that that's the parameter selected at the top of this blend tree. That's our walking setup, but we also want to set up runs, so select the lower blend tree, open up runs, and then create 3 slots for motion by clicking add motion field as we did before. Now let's take a look at how these clips are actually created. If you select the parent of runs and select any of the clips and press play, you'll see that we've created looping clips for you. Let's take a look at how we actually put one of these clips together. If you select the run clip and press the minus button, that will remove the clip from this file. We'll then recreate it so that you can learn how you actually do this with a piece of animation data. So the first thing to do is click on the plus button to create a new clip. Now this FBX file has several animation takes, some of him running to the left, some running to the right, and some running forward. First off, set the source take to the run forward, which is called run. This will automatically rename your animation clip based on that source take, so we can leave this as run. Now we have a complete set of animation data of the guy running. You can see it kind of jerks around, so it's not set up to loop properly. So what we can do is drag these in and out points like an editing package in order to set the start and end points for our character's animation loop. So what I'm going to do is find a good point where my character's thighs are together and his right foot is on the ground. Then I'm going to do the same with the end clip, because that will mean that it's matched up. So I'm going to drag back to the start to remind myself of what it looks like. And then I'm going to scroll forward until the right foot is on the ground and the thighs are aligned yet again. And you can see that Unity helps you by showing you green traffic lights when these are matched up, and a graph to show you what those particular parts are doing throughout the animation. And when I release the mouse, I can see that that's set up. So what do the other settings do? Well, first of all, I do want to loop the pose. So I'm going to check the loop box, and that ensures that I get a nicely looped clip. I want the root transform rotation to be baked into the pose of the character, i.e. baked into the animation that he's doing. And then I want the root transformation Y value to be baked into the pose as well. And finally, I'm going to leave the root transform position alone. So basically what I want to do with this run clip is to allow him to move forward in a consistent line. And if I press play, I can see that I'm not exactly getting a constant forward animation from this guy. He's kind of drifting over to one side. So the way that I can fix that is by checking that my average velocity only has a value for Z. I don't want to see anything but 0 in X and Y. So I can use my root transform rotation offset in order to fix this. I can simply drag over this watching my average velocity until it nears 0. Now that we've created my looping clip, I can hit apply at the bottom. I can hit preview again to double check it, and I can see that my guy is running perfectly in that straight line, and I can return to my blend tree to fill it in. So I'm going to reselect the lower blend tree, and I'm going to scroll to the bottom of my runs and then drag run into the center, run left into the first slot, and run right into the third slot. As usual, the lower threshold should be a value of -1, and the parameter for this to use should be direction. Your finished blend tree should look something like this, and you can name the blend trees in order to help you differentiate between them. So this is walks, and this is runs. And now if I preview, I can see my runs changing and changing direction. I can also preview the parent, changing direction and changing speed to go from a walk into a run. And this shows me how it's going to behave before I've even applied scripting to it. So now I can go back to my base layer using the breadcrumb trail at the top. And I need to create transitions from idle into locomotion. So as with before, right click on the transition you're starting from and choose Make Transition. Select the one you want to go to and then choose the transition to edit it. Yet again, I'm going to use speed. So in the condition, set the parameter to speed and we're going to say greater than 0.1. So that pretty much guarantees that the user has started pushing the forward axis, be it on the keyboard or with a joystick. Then right click on the locomotion blend tree, click Make Transition and select idle to go back. Select the transition and then set speed to a value of less than 0.1. Now that we have transitions to and from, our script will take care of the rest because it's still feeding in a value for speed and a value for direction. So if I press play in Unity now, you can see that my character can run around. He can still walk back and turn, but he can also run forward. We don't want our character to just be running around arbitrarily, we want to have our camera follow him. So let's make sure play is switched off, select the main camera, and then from the scripts folder drag on third person camera. This third person camera relies on a transform position to be added to the robot. So select the robot and drag and drop on the prefab that we've created for you called CamPos. CamPos should now be a child object of the robot, and if you select the translate tool, you should see where it is in the world. The camera will now track this position and also smoothly lean by using a lerp. You can double click and open this script to see how it works if you'd like. And again, we've commented the script to explain what it's doing. Now if you press play, the camera will track the robot as he runs around. So let's make him do something slightly more interesting than simply running or walking. We'll add in a jump animation. Make sure play is stopped and then reselect the animations folder inside the project panel. Select the animator window and drag with Alt to look above locomotion. So the animation we're going to put in is jump. So select that inside the project panel and select the jump clip we've created for you. You should see that it's a run and barrel jump and then has a few paces of run on the end of it. Because this is a single clip, we can simply drag and drop jump onto our animator. So expand that FBX file and grab the clip and drop it into the animator window. Now we're going to place it over to the left and create a transition from locomotion into jump. So right click on locomotion and choose Make Transition. Click on jump to finish the transition and do the same going back. Select the transition from locomotion to jump. And we now need to create a condition for this to happen. Now because it's simply a jump, we just want some kind of key press or button press to cause this transition to occur. And because it's a running jump, we don't want it to come out of idle, so we've just made it come out of locomotion only. So there's no way to get into this state from idle. So let's create another parameter that we can trigger using our script. Click on the plus button next to parameters and choose bool. We'll name this bool jump. And then with the transition still selected, choose it from the list of conditions. So this condition now says, if jump is true, then create this transition into jump, play the animation, and then if we select the other transition going back, we'll see the exit time, the default, is going to take us back into locomotion. A value of 0.89 basically means that around the last 10% of the jump, we're going to blend back into locomotion. So we're going to see jump occur, and then blend back into a walking or running, depending on what speed is, as part of locomotion. So how do we receive that information? If we open our bot control script, what we're doing in this is checking whether we're in a particular state, and then if we are, sending information to the animator. So our states are set up by using animator string to hash command. What this basically does is take the name of the state and convert it into an integer which we can reference. So we have a number of static integer variables, idle state, locomotion state, jump state, etc., which we've taken from what our animation states are going to be called, and that's why I'm naming them specifically as such. So jump is named jump, and it's part of the base layer, which is named base layer. So we put that into a variable called jump state, and likewise with locomotion. Down in the standard jumping area, what I'm doing is saying current base state dot name hash. So what integer is it? Is it the same as loco state integer? If so, we are in that particular state. And that's the way that we're checking which state we're in throughout the script. So if we are in that particular state, what we're doing is saying if we're pressing a certain button down, jump, which is the spacebar in Unity by default, we're setting the bool jump to true. So thereby triggering that condition from locomotion to jump. So let's switch back and see that in action. Press play. And you can now run around and press space to jump. Let's stop play and take a look at what else we can do with this animation. One cool thing about this is that now we've effectively got ourselves a character that can jump, but there is a problem with doing it in this way, because if we just jump straight into this pile of boxes, you can see that when I look back, I've walked straight into the pile of boxes, whereas really I should have jumped over the first row at the bottom. So the reason for that is that when we're jumping, if we look at our robot in the scene view, our collider remains unaffected. So if I just move my scene view to show you this, for example, I can run forward, and you can see that as my character jumps, the collider is lifted up slightly, but doesn't change shape. It remains the same height as before, whereas really our character is tucking into a ball, so we should reflect this in the collider. What we need to do here is to affect the height of the collider over time. So how are we going to do that based on animation? Well, previously, before the Mecanim system, what we would have had to do is to check certain frames of animation and find out where they were and use maybe a lerp or something like that. But in this new system, we have the ability to apply a curve to animation. And that's exactly what you'll find in the animation clips we've given you. So if you select the jump animation, select the clip, and scroll to the bottom, you'll find an area called curves. And in here, you'll find a couple of curves that we've put in. One is called collider height. It goes from the standard collider height of 2, keyframe down to a value of 1 during the jump, and then back up to 2 as we land. So what we can do with this is use this value collider height, pass it into our animator, and then use the script to set the collider for us. So in our script, we check whether we're in the jumping state and that we're not still transitioning into it. And for the purposes of the tutorial, I have a simple toggle called use curves, which you shouldn't concern yourself with, but we are setting the collider.height to the float value collider height. But we don't automatically get that from the curve. What we should do is take collider height and create a new parameter so that that parameter can be received and set to and from scripts. So collider height is something that I need to go to my animator and add in as a new parameter. So I'm going to make a new float and I'm going to name it collider height, capital C and H. The second curve that I have in my clip is something called gravity weight. This is an internal setting that you can apply to a curve in order to disable gravity during an animation. During this animation, I've keyframed using these buttons. Remember, you can edit these curves by clicking on them and adjusting them in a standard Unity curve manner. And what I've done is simply keyframe it down to 0 during the jump. This means that because we're scaling our collider right down, we don't want Unity to pull that effectively ball of a character down toward the ground before he's finished the jump, as it would kind of look unnatural. So we've disabled gravity during that jump so he gets a nice fluid jump and a scaled collider. So now that we have our parameter in place, our script in place, I'm just going to return to robot and enable my use curves checkbox on the component in the inspector. Then I'm going to switch back to my scene view so that I can show you the scaling. And if I press play and jump, you can see that during the jump, the collider is scaled. Let's see that again. And this means that I can jump over one row of boxes. Another thing to mention about how our jump works is that in the script, we're using a function called match target. Still within the check for whether we are in our jump state, we are using a raycast down from the character and checking the distance to the ground in order to match the ground as the target to head towards. We use a function called match target and use the hit point of our raycast in order to set a particular vector 3 to head towards. So a position in the world for our character to land. And throughout our animation, between point 3 and point 5 of it, we head towards the ground if our height is over the ground. So what does this mean? Well, basically during our animation, if I press play and run and jump, our character is jumping normally. But what we don't want to happen is that if we jump off of something higher, we don't want our character to land mid-air. And if we weren't matching target, he would land mid-air and then fall down with gravity. So let me just show you this briefly. If I disable that line of code and play the animation again. So the standard jump is fine, but if I jump off something higher, he lands on the air and then falls down. So our match target is basically used to pull a particular part of the character, in this case the root of the character, so pulling the whole body down towards a particular point. And all we're doing here with this mask is saying we're going to apply it to the y-axis specifically. Now let's look at how we can do a more interesting jump, which is set by a trigger. So within our scene, you should see that you have several jump trigger volumes set up around the level. So what we're going to do is apply a new script to our robot. So if you look in the scripts folder in the project panel and drag on anim triggers, this script is basically looking for something called jump trigger, and if it encounters it, it will set a boolean called jump down in our animator to true. So let's go back to our animator window and set up that boolean. So I'm going to click the plus button, choose bool, and I'm going to set up jump down, capital J and D. Now in our animations folder, we have jump down, roll and run. And in this, we've created 3 clips. A jump down, a falling animation, and then a forward roll as he lands. So we're going to set these up as 3 independent states. So expand jump down, roll and run, and start by placing in jump down. We're going to create a transition from locomotion into jump down. And this is going to be by setting jump down to true. So remember, our anim trigger script is going to set that to true, so that's going to cause a transition from locomotion into jump down. We then want to go from jump down into falling, so we'll drag that on as another state. We'll create a transition to it. I'm going to leave the condition at the default of exit time, so 0.6. So basically it's going to go into jump down and then naturally transition into falling. And then finally I'm going to bring in the roll. And I'm going to create a transition from fall into roll. And the condition for going from fall into run for the transition is going to be an exit time of 0, which again should be the default. So exit time 0 should be set on that transition. Then finally, I'm going to make a transition from roll back into locomotion. I'm going to select that transition, and yet again you should see that exit time is the default parameter for this. So it should say a value of 0.86. So now there's one final thing that I need to do before we see this in action. So if we have a look into our animations and select jump down, roll, run, what you'll see in the jump down animation is we have the use of curves yet again. This time we have gravity weight as we used before, so we're disabling gravity as he launches. And this time we have something called collider Y coming into play. What I've done here is used collider Y to set the vertical center for the collider down slightly. So I'm going from a value of 1 to a value of 0.6. So this occurs during my jump down clip. During fall, I maintain the value of 0.6. And then in the roll, I take collider Y from 0.4 up to a value of 1. So that basically means that as the guy is jumping down, the collider will move to below where it would normally be so that the feet can land on the ground and the roll can occur without digging into the ground. Now, because we've used this curve, we'll need a matching parameter collider Y to receive that information. So I'm going to copy that, make a new float, and name it collider Y. Now it should be noted that we're doing this again using the script. So if you look inside the script, you should see that collider Y is being used during the roll state, for example, to set up the Y value for the collider center. So let's see this in action finally. Press play and we'll run our character, and when he hits the trigger, he should roll and bash through the boxes. And if we show this and pause it, what we can do is have a look at our scene view and see how that collider is being affected over time. So if I select my robot and step through, you can see that as he hits the trigger, his collider is rescaled and then returns to the correct height as he lands. Now let's look at how we can use IK with Mecanim. So in Mecanim we can use IK for the hands and feet, and we can do look at for the head. What we're going to do is make our head look at a particular object in the game. We've added in this enemy object, which currently just sits in the sky and rotates slowly. What we want to do is make our character look at that object in the sky using IK, and then because this is Unity, we're going to make him fire some lasers at it too. So we'll start off by looking at how we do that inside the script. So open up the bot control script, and if you locate the area called look at enemy, you can see that if we're pressing fire button 2, which by default is the left hand alt key on the keyboard, we're using set look at position to make the head point at the enemy position. So the look at is specifically designed to work with the head, and then we simply pass in a vector 3. So enemy is already set up to find the object called enemy in the hierarchy, and we're looking at that. Now we're doing this smoothly by using a lerp to change the value for look weight from 0 to 1 based on a smoothing time value. So basically if we're holding down that key, we're going to lerp the looking towards that object, and then we're going to lerp it back if we're not holding down the key. Let's take a look at that in action. If I press play and hold down Alt, you can see that our character's head moves toward that. but we want to fire some lasers too, right? Let's do that. What we're going to do is to find some transform positions for his eyes. So if you open up robot, drill down into root, and then ribs, you should see neck, and finally head. What we want to do is to bring the camera around to where the head is looking so that you can see the head motion and also look down where the head is looking towards. What we're going to do is drag on a couple of positions for the eyes and also a camera position to move the camera towards. In the prefabs folder, you should find prefabs called IL and IR. Drag these onto the head. Basically, these are two transform positions that we've set up to act as a position at which to start a line renderer to act as our laser. We've also made this for you as a prefab because we're lovely people. So let's have a look at how we're going to actually apply this. So if you select the head, what we're going to do is to find a script in the scripts folder called laser eyes. We'll drag that on, and you'll see that it also requires an audio source onto which we'll grab the laser sound clip from the sound folder, and then the script itself requires a line renderer. So back in prefabs, find the laser line renderer and drop it on. Let's have a quick look at how laser eyes works. So if we open it up, you can see that we are creating new line renderers from the prefab. We're creating positions based on IL and IR, and we're instantiating those lasers when that particular button is pressed. So we're looking at the bot control script, we're using look weight, and we're detecting if it's been set to a value of more than 0.9, and if we haven't already shot it, then we're going to instantiate both lasers. So that look weight is basically when we are moving into using IK for look at rather than animation. So we're then playing the audio and the lasers will already be there. So if the look weight then goes down again, we destroy the two lasers, we allow the shot to be done again, and we stop the audio. Now down at the bottom, all we're simply doing here is setting the positions for our line renderers to be from the eye to the enemy. So they're coming from those 2 points and ending at the enemy's position. So now if we press play and walk around, if I hold down the Alt key, you can see he's firing lasers up at the enemy object. But we also want to move our camera into the right position so that we can see this in action. So what we're going to do is to go into our prefabs folder, find look at pos prefab, and drop it onto the head as well. So basically our script for our camera, third person camera, is looking for this particular look at pos object. And if it finds it, then look at pos is going to lerp between those positions. So if we're currently holding down the Alt key and it can find that particular transform, i.e. if you've reached this point in the tutorial, then you can lerp between those 2 points and go back when we're not holding it down. So now that we've put that into the game, and if we press play and hold Alt, you can see that we get a nice transition of the camera when he's firing at that enemy object. So that's a nice basic use of IK with a kind of vaguely practical application of it. Finally, let's look at how we can use body masking to play animation on a particular part of the body. So in our animations folder, I have one final animation to play with, something called wave. So if you select Idle's wave and press play, you should see the guy waving. Now what we want to do is to apply the animation of the arm waving, but still allow the existing animation of running, walking, or whatever you happen to be doing applied to the rest of the body. So what we can do is create something called a body mask and apply this animation to a new layer of animation in our animator. So open up the animator window and create a new layer. Click on the plus button. I'm going to name this new layer Layer 2 with no space. Then what I'm going to do is to scroll down so I can see the other settings. So you can see that in this we have a setting for masks, one for humanoid. So what I'm going to do is to select my tutorial folder and create an avatar body mask. And I'm going to call this arms only mask. Then I'm going to deselect all the other parts of the body, and I'm going to select that as the mask to use. So click on the selection button and choose it from the list. Now what you can also see here is we have blending set to override. Now the cool thing about this layer-based animation is that you can additively add animation or you can override it. In this instance we're going to override it, so we're going to override the animation that's currently on that part of the body and make him wave. But you can also additively add it. So for example, if you have a character in a game that's running around and their upper torso is kind of heaving because they're getting tired, then you can create animation that's just that additional bend and additively add it to the animation to create a much more realistic character animation. In this instance, all we want to do is add in our wave, and by default we don't want him to wave. So I'm going to start off by creating an empty state. So right click, create state empty. I don't need to name that anything because nothing's happening, and because it's orange it's the default, which is also what I want to happen. I'm going to go back to my animations folder. I'm going to select Idle's wave and expand it and grab that waving animation and drop it into my animator. I'm going to create a transition to it and one back to my empty state. I'm going to select the transition that goes to it, and in this, again, because it's just a single action, I'm going to create a button press for it. So I'm going to create a new ball. I'm going to call it wave, and I'm going to set the condition for that to if wave is set to true. So going back to my base layer, because I have this on a separate layer, during any of these states I can also control animations that occur in my second layer. So let's take a look at how we actually trigger that. In my bot control script, down at the bottom here, if I'm currently idling and I press the spacebar, then I set that ball for wave to true. So I'm using the same input as jumping because I know that I can't actually jump in idle because of the structure of my animator. So I use my spacebar again to set that ball for wave to true. And then when I actually enter that state, so I have a current state check for wave state, I set it back to false so that I can wave again in the future. Let's take a look at that in action. If I press play now, I'm idling. If I tap the spacebar, I can wave. But also if I'm currently doing other animations, so I can fire at my enemy and give him a nice wave too. And you'll see that because this is blended over the top, if I wave and then start running, even though I can't trigger them at the same point in the script, because that is still occurring, it's blended over the animation that I've got. One thing you'll notice here is that if I'm waving and start running, my other arm doesn't start swinging. So you should notice that I can correct this using my body mask. So I've put arms only mask here, but currently I'm overriding my other arm too. So if I set that back to red, I won't be overriding that part. So if I press play again, wave, and start running, you can see the other arm starts swinging as I run. So basically you can do all kinds of things with masking different parts of the body. So if you wanted to have the upper torso, for example, throwing or shooting or doing any kind of other animation, you can use this layer-based animation to blend animation over the top of what you have in your base layer. I hope that gives you some idea of the possibilities of Mecanim in 4.0, and we look forward to all the cool things that you're going to come up with as a result of this new technology. Thanks for watching.